Okay, so I promised you guys to also post a video of doing nothing but practice problems for exam 2. You already have 2 practice exams. That's separate. You have the practice exam. You have the answer key to that. But let's also do a practice problem session. All right. Now, actually, a few videos back, I gave you 2 take-home problems, which I never actually did it for you. One of them was figure out the geometry of SO3, and the other one was to figure out the geometry of SO3 minus 2. Now that we've done even more, I want you to figure out the geometry, the hybridization, and is it polar or non-polar for this. Again, you have the ability, pause my video, do this on your own, and then check your answer with me. Okay, so let's do this. SO3. SO3, how many valence electron does it have? It has 24 valence electron. Okay, because S has 6, oxygen has 6, so it will be 24 valence electron. Now, what goes in the middle? S goes in the middle, okay? And then what we're going to do, we are going to put, let me see, S goes in the middle. I'm going to draw a bond between S and oxygen. So far, so good. And then don't forget that each bond, covalent bond, has 2 electrons, right? Each covalent bond is sharing 2 electrons. I needed to remember that. Okay, so how many have I already put down? So I've already put down 1, 2, 3, 4, 5, 6. Again, valence electrons are involved in bonding, so I have 24 electrons involved in this covalent bonding. Now I need to account for those. Now each bond has 2 electrons, so I've already put down 6. 24 minus 6 is 18. Make sure you don't do math in your head on the exam. Use a calculator. So I have 18. Then I have to make sure the surrounding atoms are happy. Each oxygen has 2. It needs 6 more to be happy. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Because everyone wants to have octet, wants to have 8. Each oxygen has 2. So I'm going to add 6 more. So then each oxygen is going to have 8. Each oxygen is happy. Now, how many did I add? That means I added 18 electrons, because 3 times 6 is 18. Okay, I have no electrons left. My surrounding atom happy. Now let's go to my center atom. Is sulfur happy? It has 1, 2, 3, 4, 5, 6. Sulfur is not happy. My center atom is not happy, but I also have no electrons left. When I have no electrons left, and my center atom is not happy, that's when I make a double bond or triple bond. Now here, sulfur has 6 electrons around it, so it just needs 2 more. So I just need to make 1 bond, 1 double bond. Now it doesn't matter which oxygen I take it from. I'm supposed to take it from 1 oxygen. It doesn't matter which one you take it from. And I make a double bond. Again, it doesn't matter which oxygen you take it from at all. It's a symmetric molecule, so it doesn't matter which oxygen you take it from. I took it from the one on top. You can do the double bond here, or you can do it here. They all would be the same. Okay, so this would be my loose structure. Now, what's the geometry? Okay, let me bring up the geometry handout. Here's a geometry handout. So what is the geometry here? When you look at it, so I have again 1, 2, 3 things around the sulfur is trigonal planar. Trigonal planar. The double bond or triple bond doesn't make a difference when you're deciding what is the Vesper geometry. Okay, it does make a difference in the bond lengths, but not in the geometry. All right, so now, so far so good. Is it polar or is it non-polar? Is it polar or is it non-polar? That is a non-polar geometry. Trigonal planar is a non-polar geometry. Hopefully you got this down by now. What's the hybridization of S? Okay, remember how we talked about it. We have S, we have 3p and 1, 2, 3, 4, 5d. You have to see how many things you have around the sulfur. I have 1, 2, 3 things. So 1, 2, 3, it would be sp2. Double bond and triple bond, lone pair, single bond, all count as 1. All right, so far so good. Nice job. Let's go to SO3 minus 2. Now, SO3 minus 2, now what does minus 2 means? Minus 2 means you gain 2 electrons, right? You gain 2 electrons. So 24 plus 2, I have 26 valence electron. So I have more valence electron. Now, the same as before, what goes in the middle? I'm going to put sulfur in the middle. I'm going to put oxygen around it. At the beginning, it doesn't matter how you put oxygen around it, just put it around it. And then we said each covalent bond has 2 electrons. So how many have I already put down? I put down 6. I have 20 left. Again, just like as before, each oxygen has 2. It needs 6 more to have 8. Okay, so I added 6 to each oxygen. Now this one has 8, this one has 8, this one has 8. They are beautifully happy. So I've added 18, which means I have 2 electrons left. Those 2 electrons can be put on a center atom, and then I have no more. Is my center atom happy? 1, 2, 3, 4, 5, 6, 7, 8. Yes, my center atom is happy. My center atom is happy. Now let's go back over here. So I have sulfur, 3 bonds, and a 1 lone pair. What is the geometry? The geometry would be pyramidal. The geometry would be pyramidal. So if you want, now I can redraw it with a more correct geometry. At the beginning, just put it around it. Once you figure it out, then you can have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So this is a geometry pyramidal. Now, this is an ionic compound because it's SO3 minus 2. So they usually put a bracket and put a minus 2 outside it. Is it polar or non-polar? Again, when it has a charge, we'll just consider it to be ionic. All right, beautiful. Ready for the next question? The next question, it has to do with oxidation number. Let's do some oxidation number. Figure out the oxidation number or oxidation states for Cl and for Nd. Okay, let's do the Nd first actually. Here's Nd. The first thing you need to do before we figure out the oxidation number or oxidation states, you are supposed to do the abbreviated electron configuration. So if you look at the Nd, look at the periodic table, it would be xenon, 6s2, 5d1, and then 4f3. Okay, there's one of those exceptions. That is, you have to go down to the f orbitals. Okay, now we've talked about this. You lose and you gain from the highest n. So from the highest n, what is my highest n? My highest n is 6. Because again, as the n is higher, that means you're far away from the nucleus, so it's easier to lose or to gain electron. So the highest n is 6. So the first one I'm going to lose, I'm going to first lose those 2. So my first one is what? Is plus 2. Now, you can go all the way to plus 7, okay? So we can keep going. Let's keep going. What is my next one? My next highest one is 5, right? But before I lose this, I have to lose this one first, right? So if I add it together, it would be plus 3. Okay. Now, can I go to the next one? Let's do it. Then my next highest one is 4. Now, before I lose this, I need to lose the 2 and the 1. So 2 plus 1 and then plus 3, it would be plus 6. So you can keep going until you get to plus 7. And Nd is only a metal, and metal only have plus oxidation number. Metals only have plus oxidation number. Okay, let's do one for Cl now. The same thing. Write down the abbreviated electron configuration, which would be neon, 3s2, 3p5. What is my highest n? my highest N is 3. They both are in the same energy level. Okay, if you have the same N value, then you go with the highest L. P is higher than S. So the first one I'm going to lose those 5. Now, I'm still on the third level. I haven't reached +7 yet, so I can keep going. So then, the next one, I can lose this one. But before I lose this, I have to lose this, right? Because I can't just lose these. I have to lose those before I can lose this one. So, I have to lose these ones before I can lose this. So, if I add it together, it would be +7. Okay. Except, Cl is a non-metal, right? Now, what do we say about non-metals? Non-metals have plus and minus oxidation number. Where does the minus come from? The minus comes from how many electrons do you need to gain to look like a noble gas. If you look at a periodic table, Cl only needs to gain 1 to look like a noble gas. And that's why non-metals also have minus oxidation number, because if you just gain 1 or 2 or 3, they could look like a noble gas. Whereas metal only have positive oxidation number. So far so good? Okay. Beautiful. Nice job. Now, let's do next practice problem. You ready? Okay. Do the electron configuration. Do the abbreviated electron configuration for molybdenum. Molybdenum, Mo +2. Okay. Now, what I'm going to do, first I'm actually going to do abbreviated electron configuration for just molybdenum. If I just have molybdenum, it would be Kr, it would be 5s2, it would be 4d4. Now, if you remember, we said molybdenum is one of the exceptions, right? We said molybdenum is an exception. The ones that all have D4, they would look prettier if they would have a half-filled d orbital, right? So they would take one from the S, and then they would look like this. So molybdenum was one of the exceptions. And if you look at the periodic table, all the exceptions are in the same row. Basically, the chromium and the molybdenum were the exception, because if they gain one more, there would be a half-filled d orbitals, and that would be prettier. Okay. Now, here is molybdenum. Now, molybdenum +2. +2 means I need to lose 2 electrons, okay? What's my highest N? Here's my highest N, 5. So I would lose this one. Then I have to go to D. Then I would lose one of those. So molybdenum +2 would be Kr. The 5s is going to go away. I end up with 4d4. I end up with 4d4. So again, you lose from the highest N. I lose one from here, but I needed one more, so I have to go to D now, and I need to lose from there. So you lose from the highest, N. Okay, ready for next problem? Here's our next problem. The next problem, I want you to, let's do quantum numbers. Let's do quantum numbers. We want to do quantum numbers. Let's do quantum numbers for RH. Again, pause my video and do the quantum numbers for RH. Okay, so write the abbreviated electron configuration for RH, which would be, you do Kr, 5s2, 4d7. Okay. Now, quantum number is for the last electrons you put down. So here is our last orbital. Our last orbital is D, right? Our last orbital is D. D has how many rooms? 1, 2, 3, 4, 5. And we have 5 D orbitals, right? We have 5 of those. It's 4D is my last orbital. And I have 1, 2, 3, 4, 5, 6, 7 electrons. Quantum number is for the last electrons you put down. And remember, quantum numbers is always N, L, M sub L, and M sub S. What is my N? My N is 4 because I'm on the 4th level. So my N is 4. What is my L? My L is D, right? If you remember, we said since quantum number, you have to have a number. We have to assign a number to all the orbitals. S is 0, P is 1, D is 2, and F is 3. So this one is D. What would D? D would be 2. M sub L. Okay. Remember what we talked about? We said, again, we have to give a number to all of these because quantum number has to be numbers. Now, M sub L is, what is the orientation? The orientation is right here. This is the house is in. This is the house the last electron is in. So it would be minus 1. M sub S. Is this up or is it down? This is down. Because it's down, is minus half. If it was up, it would be plus half. Okay, so far so good? Okay, that's a little review for quantum number. All right, ready for the next question? Okay, here's our next question. Rank from lowest to highest of ionization, not energy. What I meant to say, okay, so rank highest to lowest to highest ionic radius. Let's do that. Let's do ionic radius. Okay, pause me and do this problem. Lowest to highest ionic radius. Now remember, we said before you do this, you have to write down the trend. The trend for atomic radius and ionic radius is this, going this way and then going down. And we said the trend for everything else, ionization energy, energy affinity, electronegativity, would be the opposite of this. And we explained why that is. Then we said put these atoms relative to each other on the periodic table. Okay? Put them relative to each other. If I do that, it would be F minus would be here. Cl minus is over here. And then sodium would be on the same row. And then here would be potassium, and here it would be the Br. Okay. Now, we look at up and down first because that matters more because of the N value. So these two are my highest size. These two are my highest ionic radius. Okay. Now, except we said if you're on the same row and you have charges, the charges get priority over the trend. So, and we say the more minus you are, the bigger you are because minus means you gained electron. So between these two, which one is going to be my larger one? Br minus will be my largest one. Then it's going to be K plus. Okay. Now I'm going to go to the next row. Next row, again, you have to go up and down first. Next row, these two are on the same row. If you're on the same row and you have charges, the minus will win. The minus will win because you gained electron. Okay. Now, what's going to be my smallest one? My smallest one is going to be F minus. So this will be like, again, put an electron relative to each other and then do this. And then the only thing for ionic radius is tricky is like if you're on the same row, the charges will take the priority. Okay, nice job. Ready for next practice problem? Let's do it. Okay, so read this question because don't forget that part of this exam is actually concentration and dilution problem. When you read this question, this is a dilution problem. Why is it a dilution problem? Because the concentration is changing. They ask you what's the new concentration. When we do this, the concentration is changing. Okay, what is my original solution? Whenever we have a dilution problem, you have M1V1, M2V2. Don't forget that. Every time we have a dilution problem, we have M1V1, M2V2. Do not forget that. What is my M1? My M1 is 0.10 molar. How much of it do I have? I have 20 ml of it. They're asking you what's my M2. My final volume is 200 ml. Now, if I do that, what my M1 is going to be is going to end up being 0.01 molar. Okay, so again, Don't forget, this is part of this exam. It has to do with concentration and molarity. So make sure you get those down. Okay, ready for last question. Okay, here's the next question. And it says, what's the wavelengths in nanometer in a hydrogen atom when we go from N5 to N2? And I'm not going to go over this question because there's a question just like this on your exam. So I'm going to leave this to you to do a practice problem, go to the SI session, go to the workshop, use the resources you have to work this out because this is on your exam. I want to give it away to you guys, but you have to find the answer. Now, on the exam again, I will give you all of the constant. I will not give you the equation. And just by looking at this, you know that you're going from N5 to N2. So that means you're going to go from N5 to N2. Is that emission or is that absorption? So you already know that this is the emission, right? Okay, that's the only hint you get. So work on this one because this question might just show up on your exam. Okay, study hard.